Hello everyone, welcome to Recitation 0J. Today we are diving into the world of PyTorch and exploring a crucial component for efficient and smooth neural network training, the PyTorch data loader. So we aim to cover the following topic in this recitation. Introduction to PyTorch data loader, how to initialize a data loader object, handling different batching strategies, customizing data loading with collect functions, leveraging multiprocess data loading, and also optimizing training with pin memory. So during the process of training a model, we need to fit the data into our model batch by batch for the model to update its parameters. So without a data loader, we'll need to manually feed the data and we will need to slice them using PyTorch arrays into small batches as the pseudocode shown here. To efficiently fit data to our neural networks during training, we use the PyTorch data loader. It helps us to handle various aspects like batching, shuffling, and multiprocessing. So if we are just using a for loop here, firstly, it's not randomized, and secondly, it's not parallelized, so it could be much slower compared to using a PyTorch data loader. So now let's dive into how to set it up. So in PyTorch, we first need to create a custom dataset class. And this class defines how to access and pre-process your data. For instance, here we have a sample data loader, and we want to train a model to learn that the target is 2 times the input. And hence, we have the following data set. The input is a list of numbers from 0 to 9, and the target is the twice of the input. So here, let's look at different ways of creating the data loader. So firstly, if you just call the data loader with only the data set as the input without any other arguments, by default, the batch size will be 1. So we can see that each input has only 1 element, and also the label has 1 element. And we can see that the data is loaded in the order that of the data set, how it was created without shuffling. So here, if we want to pass in a batch of 4 data in one batch, we can put the argument batch size and set it equal to, for example, 4. And here we can see that now the batch of data inputs has 4 elements, and correspondingly the labels have 4 elements. And even better, if we want to make the model more robust, we can shuffle the data. So note that the shuffled data not only shuffle the order of the batches, but it shuffles how the batches are constructed. So instead of a batch of 0, 1, 2, 3, now we randomly select the indices of the batch. And lastly, if we can see that this data set has 10 samples, and if we set the batch size equal to 4, there will be a batch with only 2 elements. And if we don't want a particularly small batch during our training, we can set the drop last argument to true. And here we can see that we will only have 2 full batches of batch size of 4. And the last batch will be automatically dropped. So batching is a very crucial concept in machine learning. Larger batch size increases the memory usage, but can speed up training. While smaller batches might potentially provide better generalization. However, it's really slow if you have to feed the data one by one to the model. Now let's look at the collate function. So why we need the collate function? Sometimes we need a custom pre-processing on batches, and we achieve this through the collate function. It let us perform transformations on the batches. For example, if you want to normalize on the batched data, you can, this exact example, normalize the data within the batch, and you'll get the results here. So this is a particularly useful trick for data pre-processing. In later homeworks, sometimes the data will have the different data types, or you want to stack the data in different dimensions other than the default, the first dimension. So you will need to write your own collate function to create the batch of data. Now we want to utilize the GPU for faster multi-process data loading. So this can be achieved very easily by using a data loader. Simply indicate the argument num workers. You can set it to 2 or 4 or even higher, depends on your GPU. So if you can increase the number until you see a warning. And lastly, we have the pin memory option. This option gives us this option copies data into pinned memory, which can be particularly beneficial when using GPUs. So when we set pin memory to true, PyTorch will copy data to pinned memory, enhancing data transfer speeds between the CPU and GPU.